So in the previous video we have seen all the questions related to the differential calculus, and today we'll start with basically integral calculus. And in that specifically today we'll discuss top concept of basically Riemann sum or a limit of a sum, integration of limit of sum. So there were only 2 questions asked on this topic, and and these are fairly straightforward questions and very easy questions. Like if you know the basic formula or the definition of the Riemann sum or integration of limit of sum, then you'll be able to solve these questions. So let's see both the questions one by one. So question 1 says that find the limit. So basically we're supposed to find this limit. So first let us see that what is basically Riemann sum or integration of limit of sum. So in integration of limit of sum, a to b fx dx is basically defined as limit n tends to infinity, summation r is equals to 1 to n del x into f of xn, where del x is basically length of interval. In that case we are assuming it as b minus a divided by n if there is a partition with n subintervals, and x of r is basically defined as a plus r into del of xr, that is basically a plus r into b minus a by n. So what we'll do is, so in these type of questions you are basically supposed to reduce your function in this format, and so that you can basically apply the integration to solve the limit. So let's see our question. So the question is, let us assume that LB limit of the required thing that we are supposed to calculate, that is limit n approaches infinity, 1 by n square summation r is equals to 0 to n minus 1 under root of n square minus r square. Now if you see that this summation is varying over the values of r, not the values of n, so I can just take this n square thing inside the summation. So that will basically give me, or what I'll do is I'll just pull out n square from this under root. That would be a better way to do it. So it will be limit n approaches infinity, 1 by n square summation r is equals to 0 to n minus 1. Here is also it's 0, so it is, if I pull out n square, it will be n under root 1 minus r square by n square. And if I simplify it, and since the summation is varying over r, I can pull out this n outside r as well, right? Outside this summation sign as well. So if I do so, I'll get limit n approaches infinity, 1 by n square into n under root b into n summation r is equals to 0 to n minus 1 under root 1 minus r square by n square. This is basically equals to limit n approaches infinity, 1 by n summation r is equals to 0 to n minus 1 under root 1 minus r square by n square. Now if you see that our function, basically our limit, reduced to the required format, that is we have our del x as basically 1 by n, del x is equals to 1 by n, and f of x of n is basically under root 1 minus r square by n square, and that's, and our del x is basically 1 by n. 1 by n is equals to b minus a by n. So from here we can say that our b minus a will be 1. So we can say that our limit L, our limit, that is summation r is equals to 0 to n minus 1 1 by n under root 1 minus r square by n square is in form of Riemann series. Such that Rn is basically equals to summation r is equals to 0 to n minus 1 by n under root 1 minus r square by n square. So we have concluded it till here, and further we have seen that our b minus a is basically equals to 1. Now using the definition of del xr basically, so our xr is basically equals to a plus r into del xr, that is equals to xr is equals to a plus r by n, because for our case our del xr is basically 1 by n. So from here if I put r equals to 0, that will give me x0 is equals to a plus 0 by n, which is, and my initial limit x0 is basically 0, so that basically gives me a is equals to 0, and using this relation b minus a equals to 1, I can say that my limit my b will be 1. So now let's just substitute in the integration of Riemann sum. So that will give me this limit, that is L is equals to 1 by n summation r is equals to 0 to n minus 1 under root 1 minus r square by n square. So using the definition of Riemann sum, we'll get it as integration 0 to 1 under root 1 minus x square dx. And we know that this thing is integrable, and we can integrate it using basically the integration by parts thing. So that will be x into under root 1 minus x square by 2 plus sine inverse x by 2, and its limit varying from 0 to 1. So this will be 1 by 2 under root 1 minus 1 square plus 1 by 2 into sine inverse 1 minus, it will be 0 by 2 under root 1 minus 0 plus 1 by 2 into sine inverse 0. So this term is 0, likewise sine inverse 0 is 0 only, so this term also goes to 0, and 1 minus 1 is 0, so it also reduces to 0. So we are left with 1 by 2 into sine inverse 1, that is 1 by 2 into pi by 2. So from here I can say that my limit L is basically pi by 4. In the similar manner, we'll move on to solve the next question. That is, they have defined us a sequence Sn of real number, and it is defined as Sn is basically summation I is equals to 1 to n log n plus I minus log n whole square divided by n plus I. And we are supposed to check if this limit exists, basically limit of Sn exists, and if it exists we are supposed to compute value of this and justify our answer. So first let's just simplify this Sn in terms of, like, to make it in form of Riemann sum. So Sn will be basically summation I equals to 1 to n log of n plus I by n whole square divided by n plus I. Here I have used this relation, that is log of b by a is equals to log b minus log a. Now I can write it as summation I is equals to 1 to n log of 1 plus I by n square divided by, I can pull out n from here, so I'll get 1 plus I by n, and it will be equals to summation I is equals to 1 to n 1 by n into log 1 plus I by n square divided by 1 plus I by n. Now if you see that this has, like, we have reduced it in Riemann form, that is it's in Riemann series basically, such that my Rn is basically equals to summation I is equals to 1 to n log of 1 plus I by n square divided by 1 plus I by n into 1 by n. Now if I just compare it with that, so I'll get my del x as 1 by n, and that is basically equals to b minus a by n. So from here also I got my b minus a is equals to 1. So it is a relation 1. Let's name it as star. Further, we know that x of r is equals to a plus r into del of x. That basically gives me x0 is equals to 0 equals to x0 equals to a plus 0 into del x. So from here I got a is equals to 0, and using this relation star, I got my b as 1. So let's reduce it in integral format. This limit L, limit n approaches infinity, Sn will be basically equals to 0 to 1 log 1 plus x square divided by 1 plus x dx. Now to solve it, let us assume that u is equals to log of 1 plus x. Now if you take its derivative, it will be 1 by 1 plus x into dx. So using these relations, if you change the limit, it will be 0 equals to, when x equals to 0, u is equals to log 1, that is 0, and when x equals to 1, u equals to log 2. So let's just reduce it. It will be limit n approaches infinity, Sn is equals to 0 to log 2 u square du, because dx by 1 plus x is du. So it will be u cube by 3 and limit varying from 0 to log 2. So if you simplify it, you will get log 2 cube minus 0 cube divided by 3, that is 1 by 3 into log 2 cube, and that's the final answer. Basically that's the limit we are supposed to calculate. That's the value of a limit of Sn basically as n approaches infinity. So these were the only 2 questions asked on this topic, and yeah, so we'll discuss maybe the definite integral in the next part of the series. So thank you for watching, and if you like the video, then please do share and subscribe the channel. Thank you.